let's see if we can clarify this, meaning that we can get this a little clearer so that it doesn't have a color to it, maybe get rid of an odor in that. And to do that, the key ingredient is going to be charcoal. So we're going to actually swirl this around with charcoal, mix it up good. Charcoal is good at adsorption, where things that are chemicals that have a scent to them or that tend to make liquids cloudy will actually stick to the charcoal. Once those objects are stuck to the charcoal, then we'll be able to strain or filter those out through a very fine filter. And then from there, we should have a lot cleaner water. So let's take a look at that by setting up this charcoal absorption setup. So to do this charcoal absorption setup, I'm gonna take our black charcoal powder here. It's very fine. Put about 1.5 scoops, all right? And then I'm going to fold this paper towel and slide it in to this Erlenmeyer flask. Now this is the same glass as a beaker, but an Erlenmeyer flask has a different shape to it, so keep that in mind. This is a beaker, this is an Erlenmeyer flask. So let's put this charcoal into the Erlenmeyer flask. Nice. Okay, if we didn't make too big of a mess, that's great. Now we have our black charcoal in there, and now I'm going to take our water sample, and I'm going to put it inside the charcoal. Now you might be thinking, wait a minute, we're supposed to be cleaning this. This doesn't look any cleaner. Now the liquid is black. Well, that's true, but we're gonna stop at the top. We're actually gonna swirl this around for a good couple of minutes. By doing that, all those little things that are floating in the water that are impurities, the things that are making it smell, it kind of smelled strangely like spicy or garlicky something, I don't know what it was. Some of the leftover tiny microscopic oils maybe, the things that are potentially making it cloudy, all of those little particles can start sticking to the charcoal. Charcoal naturally absorbs things, okay? From there, we're going to clean this water out then through filtration. And to do that, notice I'm still shaking it, trying to interact the charcoal with the impurities. We're gonna take filter paper. If you think of how coffee works, you put a coffee filter down, you pour hot water over the coffee, and what comes out? The coffee grounds stay behind in the filter, and the liquid comes through, so you get your delicious hot cup of coffee. All right? Well, that's what we're going to do, but with science filter paper. So I'm going to shake this a little bit more, and I'm going to set up my filtration system, and we can go from there. But let's take a break so you don't have to watch me shaking this for a couple minutes. So we've shaken our water, I think, enough. So I'm going to show you how to set up a little filter paper action here. So when I have these white circular filter papers, I'm going to fold it in half like a taco. And then I'm going to fold it in half again, to make it look like a slice of pizza. Then I'm gonna fold it in half again to make it look more like an ice cream cone. But when I unfold that, it's now made these natural edges that can accidentally fold over each other to make this round cone-like shape. So if you mess with it enough, you're gonna see that it's gonna fit right into our funnel nicely right there. Okay? Now what you don't see maybe at the bottom here is that I have a nice clean rubber tube coming from the funnel, and I have a nice clean beaker. So what I'm going to do is I'm going to put my funnel up high, and then I'm going to slowly pour this thick black water through this filter paper. Now if I pour it carefully, the filter paper should hold behind all of the charcoal and all of the impurities that stuck to the charcoal, and nice, clean, clear water should come out. I guess we'll see though. Let's go ahead and check. So I'm gonna actually angle down the camera, and we'll see if the water that comes out is clear. So I'm gonna pour this into the filter paper, and it's coming out thick black, but let's see what comes out towards the bottom. Ah, awesome. If you can see, the water's already trickling down, and it's probably hard for you to see because it's clear. That's right. Our water is coming out crystal clear. The charcoal did a great job of sticking to the impurities, but now that filter paper, gravity's pulling the water down, but the filter paper won't let the charcoal through. Just like a coffee filter. The coffee grounds can't go through, just the liquid water can. It's another form of physical separation. So this is pretty awesome, and when we do this in class, a lot of students are shocked how clean the water's coming out. They don't believe it. But again, if you ever make coffee, you've seen this phenomenon before. It's just filtration, and you're using gravity to pull the liquid down. All right, this is gonna take a few minutes because this filter is so fine. So we're going to give this a few minutes to let the water leak out. And once we do, we'll finish up our data table, answering questions like the volume, the color, the clarity, and that. So take a quick break here. I'm gonna turn off the camera and we'll come back when we're ready to rock with our final sample. So we're back and we have officially filtered out the charcoal. Take a look at that. The filter paper left all that charcoal behind, and look at our clear water sample. Wow, awesome. So it's amazing what physical separation can do to clean water. So let's do a couple last pieces of data. I'm going to measure the final volume in my graduated cylinder. And if I look at it eye level, it looks like it's at 65 milliliters. So quite a bit of the liquid was lost in these final few steps. We started with 100 milliliters and now we have 65 milliliters of water left. Let's take a look at that color. No longer cloudy, brown, or yellow. That's a nice clear color, right? Also clarity. No longer yellow or brown for clarity. This is nice and clear. So clarity is clear, all right, not cloudy. Odor, there's actually no smell left to it. The charcoal did a great job of removing the smell. There's no oil in it, it's nice and clear, and there's no solids either. So this is nice and clean. Now a common question is, well, can we drink it? I wouldn't in a lab because of all this different glassware. We never know where this came from. Also, one thing we didn't account for technically is bacteria growth. How old is this water? Is there bacteria? Physical separation can't necessarily separate out the bacteria that could eventually make you sick. So in Always in Labs, we're not eating or anything like that. But if you were on a deserted island and somehow had all this stuff, you'd have a lot cleaner water than you started with. I would probably boil it first to try to kill off any germs, but then I'd be pretty confident that it would be pretty clean water. Nice job following along, and now you have your data table, and you can answer the remaining questions that follow up with this lab. So thanks for sticking with us, Science Fam. Best of luck with the rest of the lab, and let us know if you have any questions. Be well.